use direct integration to find the Fourier transform of dB of t is equal to delta of 2t minus 1 plus 2e power minus t u of t minus 1. Okay, so this is our given function, and to find out the Fourier transform we use this formula gb, capital GB, that's a Fourier transform in the frequency domain. This is going to be negative infinity to infinity, and whatever the function we have, in this case we have gb of t, and then we multiply that function with e power minus 2 phi ft, and then we integrate this one with respect to time. Okay, this is the formula we had to use, and if we substitute gb of t with this equation right here, it's going to come like negative infinity to infinity, and then we are going to have delta of 2t minus 1, and you can put all together and multiply by this e power minus 2 phi ft, or you can separate individually, because after you multiply everything together you have to separate anyway. So I'm gonna do that step together, like I'm gonna do the separation right away right now. So delta of 2t minus 1, and then e power minus 2 phi ft comes right here, and then we integrate this one with respect to t, and then plus we have 2 e power minus 4 minus t u of t minus 1. 2 is a constant, so we can bring it to the front, and then integration negative infinity to infinity e power minus t, and then u of t minus 1 multiplied by e power minus 2 phi f 2 phi f t dt. Okay, and here we can do some simplifications. For impulse function, impulse function only exists at time t is equal to half. I mean, at time 1 usually, but here in this particular situation, this is 2t minus 1. Okay, so like impulse function always happen at 0, location 0, if you don't have any shift, but here we have some shift, so this is going to happen at t is equal to 1 and divided by 2, 1 over 2. It's going to happen at 1 over 2. So the answer for the, usually, if you, so what's going to happen is this impulse function is going to happen as t of half, so the integration is going to happen at half only, positive half. Okay, so we can just do the integration directly, and the integration of an impulse function is always 1, and if we get rid of that, then it's only integration of this, and for that one we are going to have e power minus 2 phi ft, and the time is going to be just half. Okay, time is going to be just half. Okay, and also so there's a property we have to use here. Let's analyze the property. There are some properties comes into play when you do that. So these are some properties. When you integrate something, an impulse function, okay, you can rewrite the impulse function like this: delta of at is 1 over a delta of t. Okay, so it's better to do that first. before we do the integration. So this is let's look at that again. Delta of AT is equal to 1 over A, and if we have a shift in delta of AT, it's basically 1 over absolute value of that number, and then t plus minus whatever the shift is. So here, if you look at this one, here we have something here, right? So we have to look at what value we have, and when we solve for, we have to just separate t. So if we solve for t, 2t minus 1 is 0, therefore t is going to be equal to 1 over 2. So this is going to be 1 over 2 integration negative infinity to infinity, and then delta of t minus half. Okay, so that's the property we have to use right here. And since this is only going to happen at time half, we can replace this time with 2 phi f times half. Okay, so once we do that, we don't have any this is going to become a constant because we don't have t anymore, so we can move that to the front. And let's deal with this one. So here we have a unit step function. Unit step function only happen at 0, and then unit step function is basically 1. Unit step function is equal to 1 when t is equal to 0 or greater than 0, and otherwise is 0, else 0. So if it's mean we are not going to have a situation that is less than 0, but if we have a shift we have to be careful. So here we have t minus 1, so this is u of t, and for u of t minus 1, it's going to be 1 when t is shifted 1 unit to the right. So it means when t is greater than or equal to 1, and 0 else. Okay, so it's going to go from 1 to positive infinity. So the limit here is 1 to positive infinity. And once we do that, then unit step function is just 1 over there, so we can just put 1, or we can just make like it just multiply by 1. Anything multiplied by 1 is going to be itself. So this is 1 to infinity, and then e power minus t multiplied by e power minus 2 phi f t 2 phi f t dt. Okay, so let's continue here. ah okay, so this is a constant. For the first one, the e power part is a constant, so we can move that to the front. E power minus 2 phi f f times half, or you can just cut off this half and 2, so it just becomes e power f phi f. Okay, I made a mistake, like there should be a j over everywhere. There should be a j, so this is j, then here also j. So this is 2 phi f j here. And then after that we are going to have integration from negative infinity to infinity delta of t minus half dt. And if you integrate an impulse function, that's always 1, so this part is going to become 1. But let's look at the other one. We can integrate, but before we do the integration we can combine them together, like 1 to infinity, then when the e power e multiply, the power will add up. So what we can do here is we can take the minus common, so this will be g plus j25f, and then also, okay, we can also take the t common as well, so this is 1 plus j25f and then t, right, dt. If we do that, the integration become a little bit easier. So here we are going to have half e power minus 5 fj, or you can say j5f, that's better way to write. And this integration is 1. If you integrate an impulse function, that's 1, so we can just leave it as it is right here. And then here this is 2 times. The top part remains the same when we do the integration, e power minus 1 plus j25 f t, and in the bottom part we are gonna have this the power part alone except the t. This is minus 1 plus j25f. Okay, so upper limits of integration is infinity, so if you plug infinity for the t value, this is e power negative infinity, so you're going to get 0 for that. When you apply the upper limit, that's going to become 0. Okay, here we are, our upper limit is infinity and the lower limit is 1. So when we apply the upper limit, that make the whole thing 0, and when we apply the lower limit, that is like upper limit minus the lower limit, so we are going to have a negative sign in front, so the negative and the bottom negative will cancel, so we are going to end up with a positive anyway. So finally we are going to have half e power minus j5f plus 2, then we are going to have e power minus 1 plus j25f and multiply by 1, so it's going to be like this, and divided by, this is going to turn into positive because of the subtraction we are going to have when we subtract upper limit minus lower limit. So minus cancel and become plus. This is going to be 1 plus j25 fj, j25f, that's our final answer. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.